Hello guys, this is Dr. Parth Fanse. We are going to talk about pediatrics today. And in pediatrics, we will start with very basic definitions and then we'll continue with more in details. Starting with very basic definition, that is growth. So what is growth? Growth is nothing but it is increase in size of an organ or a body. It is increase in size of an organ or body. This can be viewed as in two ways. Either it can be increase in the size of a cell, increase in size of a cell, or it can be increase in number of cells. So growth can be differentiated by either in increase in size of a cell or it can be increase in number of the cell. Following to the next definition we going to discuss is about development. Now what is development? Development is nothing but it is maturity of our bodily functions. It is maturity of our body functions. Whatever the functions are performed by our body and then we show some type of maturity, it is called to be development. What is growth? Growth is increase in size of an organ or body, and development is nothing but it is maturity of the functions. Continuing with the same thing further, we want to discuss about some stages of life. Starting with very basic one, that is ovum. What is ovum? Ovum is a stage of a life which is called to be from 0 to second week of a life. Followed by embryo. Embryo is nothing but it is product of conception from third week till 8th week of our life. Coming to the fetus, fetus is nothing but it is a product of conception from 9th week till birth. It is called to be fetus. And then followed by a perinatal period. Perinatal period is nothing but it is a period of 22nd week of gestation, 22nd week of gestation till 9, sorry, it will be till 7 days of postnatal life. After perinatal period, we want to discuss about neonate. What do you mean by neonate? Neonate is a period of our life which is called from the first day of life till 28 days of life, or we can conclude it as this 28 days of life can be concluded it as 4 weeks of life. In an MCQ, it can be given in either way. So we need to understand either it is given in days or it in weeks. Then followed by a infant. What is an infant? Infant is a child with, we can call it as an infant till a child celebrates its first birthday. Means till 1 year, it is called to be an infant. Then followed by what is a toddler? Toddler is a person or a child which is nothing but it is 1 to 3 years of its life is called to be toddler. Followed by toddler, we need to learn about three ages, that is preschool age, school age, and adolescence. We'll talk about in details what is preschool age. Preschool age is nothing but it is a age of a child from 1 to 3 years of its life. Followed by school age. School age is nothing but a child's age between 3 to 6 years of life. Now, yes, adolescence we want to discuss. Adolescence is further differentiated into three parts or basically three groups. Adolescence has been differentiated as early adolescence, mid adolescence, and late adolescence, where early adolescence is a age when a child is between 10 to 13 years of age. Mid adolescence is nothing but it is 14 to 16 years of life, and late adolescence is between 17 to 19 years of life. So this was the basic definition what we were discussing. Now coming to one liners what we need to remember for our exam, there are some one liners what we need to remember for our exams. So starting with the first one is nothing but it is on what hormones, or we can say it as what hormones are responsible for the growth of child, no, for the growth of the fetus. Which three hormones or what hormones are responsible for the growth of the fetus? There are three hormones which are responsible for the growth of the fetus. How many hormones? Three hormones are responsible for the growth of the fetus. We can name it as, the first one is insulin. First one is insulin, second one is thyroxine, and third one is cortisol. See, every hormone have its own function, have own importance. Which is the most important for a growth of the fetus is nothing but it is insulin. Most important for growth is insulin. You may amaze that why growth hormone is not responsible. Yes, growth hormone is not responsible, but for most important hormone for growth of a fetus is nothing but it is insulin. Followed by thyroxine. We very well know hormones of thyroid from thyroid gland are responsible for metabolism. So yes, thyroxine is also important for the growth of the fetus. Followed by cortisol. Cortisol have its own function. It is for pulmonary growth and other development of the body. Yes, pulmonary growth means we are talking about lung maturity and so on. And for lung maturity, the hormone which is responsible is nothing but it is cortisol. And there can be a liner, one liner can come arouse in your question. Do growth hormone have its function? Yes, there may be a reason. There may be a thing where growth hormone can play a particular part for growth of the fetus, but there is no much role enough growth fetus. So we can write it as like it is a least important. It has least important role in growth of fetus. So am I done with this thing? So this was about one-liners about the hormones responsible for the growth in fetus. Then we talk about stature. One more one-liner what we need to remember is about stature. Stature is nothing but it is a term used for height. And now stature or height of a child will depends upon height of parents. It depends upon height of parents as well. There is a parameter in pediatric, or it is called to be lean body mass. So there are two factors which are responsible for the stature or height of a child. The first one is, yes, it depends on the height of a parents, and there is one parameter in a pediatric which is called to be lean body mass. Now there may be a question, if a better lean body mass, I'm writing in a very short, that is LBM, a better lean body mass, it can be like a child. We can term it in child as well as adult. Now, what is in child? If there is a better lean body mass, there will be a better height. If in adult we use this parameter about LBM, that is lean body mass, by this we can term it as better fitness and better cardiovascular health in adult. So which parameter do we use for better health in adult one? That is nothing but is lean body mass. Similar, the same parameter we use for better height measurement in pediatric students or pediatric child. Now, follow to the next one. One more one-liner what we need to remember is, in a 10-year-old child, in a 10-year-old child, in a 10-year-old child, height of a child will be equal to its arm span. Means what? A height of the child will be similar to a span of a baby. When you measure from this finger till this finger of the both opposite hands, it is height of a child will be is equals to arm of span. It will be noted at the age of 10 years. It will be noted at the age of 10 years. But there can be some case where height is less than of arm span or arm span, whatever word do you use. There can be some condition which can we can note. For again, I'm writing height will be lesser than arm span, or in another words what I can write is arm span can be greater than height. This is an indication for various syndromes This can be indication for various syndrome which we can note in a children. One condition when you can record more than 3 centimeter arm span than as the usual height. This is an indication for a Marfan syndrome. This can give an indication for Marfan syndrome. Then there can be an indication, it can be an Ehlers-Danlos syndrome, or maybe there can be an indication for Klinefelter syndrome. But basically, we indicate this parameter along with the Marfan syndrome. The most commonest question which comes in MCA exam about this indication is nothing but it is Marfan syndrome. There are other syndrome also which are not more reliable, but it is homocystinuria and Sotos syndrome. We'll do study this syndrome in a later half, but just remember the homocystinuria and Sotos syndrome are also related to this arm height spine wala topic. Now there are some graph what we need to study about which can come as an image based questions, and there are criterias along with this. I am drawing a graph. Yes, it cannot be perfect as it should be, but yes, I am trying my best to draw. Let's have a graph. When you observe this kind of graph, where this is nothing but it is age in years. The first graph what we want to study is in age in years. For example, consider this to be 0, 2, 8, 12. So this is nothing when, and this is around growth. This is x-axis, this is y-axis. We noted in an x-axis is nothing but it is age in years, while y-axis have been plotted as growth. When you observe this kind of graph in your exams, this is a graph of a brain or neural development which increases along with the age. So this graph is about brain and neural development. Second graph we need to study is about growth in somatic cells. I am again writing somatic. Growth in somatic, or we can term it as general growth. This graph can be studied in a similar manner what we studied the last one. We are plotting x-axis in terms of age and y-axis we will determine in basis of growth. Following to the graph, when we observe this graph, this shows a sigmoid kind of curve. We show a sigmoid kind of curve, and this shape is also called to be somatic shape curve or somatic curve. And the shape for this somatic growth to have is called to be sigmoid curve, because it shows a sigmoid like turn, sigmoid like shape we observe in a graph. That's the reason why it is called to be sigmoid curve, which is considered in a somatic or general growth. Third graph what we want to study is about lymphoid tissue. We want to study a graph of a lymphoid tissue. In a lymphoid tissue, we won't change our parameters on x-axis and y-axis. Again, I'm noting it as in terms of age, and this is nothing but it is growth. There is an interesting graph in lymphoid tissue which shows, consider this to be an 100% growth. In 100% growth, yes. So in 100% growth, lymphoid tissue shows a certain consider graph like this, and then it decreases. So what happens? This is called to be a lymphoid tissue growth graph. Lymphoid tissue or growth graph. Yes. So moving to the next graph and last one, what we need to study in our today's schedule is nothing but it is gonadal growth. So fourth graph, what we need to study is about gonadal growths. Again, we are going to draw the same type of graph, x-axis, y-axis, and x-axis, as we did before, it will be like in the same manner, and y-axis will be our growth. Till puberty, we do not see any sort of greater development, but when a child attains a puberty, there is a severe growth or a notable growth is seen in gonads. So this graph will be in this manner. Once a graph in this manner, if a growth against age against growth graph will be seen, and when you can see this type of graph, it is called to be gonadal growth graph. It is called to be gonadal growth graph. And this gonadal growth graph will be opposite to the brain or neural development, which you can basically differentiate. This is brain and neural development, and this is a gonadal growth, which are opposite to its niche. Now there is one phenomena what we want to study. It is called to be ready reckoners in anthropometry. And my dear fellows, please, this is one of the most important topics. I am even mentioning it is very important, as you can see one or two MCQ from this phenomena. Let's study what is ready reckoners. So consider a body weight equals to x. A body weight of a child equals to x. Okay. Now, when a child attains a age of 5 months, it will be multiplied. It will be double. So we can write at the age of 5 months, the growth of a child will be at two. I mean, body weight of a child will be 2x. When a child attains one age, it will be 3x. It will be 3x. When a child becomes 2 year old, it will be 4x. When a child attains the age of 3, it will be 5x. When a child attains a age of 7 year, when a child attain a age of 7 year, it will be 7x. You may have a question, what about 5 year? 5 year will be 6x. 7 year will be 7x, and 10 year will be 10x. So you need to remember at each point, whatever I have mentioned over here, that for body weight equals to x, when a child gets birth, the body weight equals to x. At 5 months, it will be 3x. At 1 year, it will be 3x. At 2 year, it will be 4x. At 3 year, it will be 5x. And at 7 year, it will be 7x. And 10 year, it will be 10x. Am I done with this thing? So, when we talk about one more phenomena, that is about length and height. We are talking about now length and height. Now, usually, when a child takes birth, length at the time of birth is around 50 centimeter. This is we are taking on a basis of on as an average. So when a child takes birth, length of the baby is considered to be at 50x. We are taken as a mean value. When a child attains the age of 1 year, it attains a height of 75 centimeter. When a child attains the age of 2 year, an average is 87.5 centimeter to 90 centimeter. And when a child attains the age of 4 year, it will consider to be as 100 centimeter. And please don't mistake this, don't get mistaken over here in this thing. This is an average value which we do observe in a pediatric ward. So when they ask you what will be an expected value, when they ask you in MCQ what will be the expected value of height at a certain age, so what will be your answer? Expected height in centimeter, expected height in centimeter between age 2 to 12 year. expected height in centimeter between the age 2 to 12 year will be equals to age in year multiplied by 6 plus 77. So this is a formula what we need to remember. It is age in year multiplied by 6 plus 77. It is age in year multiplied by 6 into, sorry, age in year multiplied by 6 plus 77. Let's take an example. What age will be there of a child of 2 year? Child is of 2 year. So expected height is equals to age in year multiplied by 6 plus 77. So 2 into 6 plus 77, that is 12 plus 77, which is considered to be 89. This is an average value. You have to choose an option nearby, which is given in your MCQ. Am I done with this thing? Okay, moving to the next. It is at what time the adult height will be half at pediatric, I mean of child. At what time child height will be half of the adult? So it will be around 2 years. It will be around 2 years, or you can write it as 24 to 30 months. 24 to 30 months. Okay. Now there is one more parameter. What we need to do is MPH. Guys, this is not Masters in Public Health. It is mid-parental height. One more parameter what we need to study is nothing but it is mid-parental height. And there are two different definitions for boys and girls. I mean, there are two different formulas for boys as well as girls. If we talk about boys, it is father's height plus mother's height by 2 plus 6.5 centimeter. Again, what is mid-parental height for boys? It is nothing but it is father's height plus mother's height divided by 2 plus 6.5 centimeter. While if we talk about girls do have a same parameter. This father's height plus mother's height by 2, but you have to do minus 6.5. So I am mentioning over here father's height plus mother's height when you divide it by 2, but in girls you have to do minus 6.5 centimeter. I'm encircling this a difference between MPH in boys and girls. Please don't make mistake. Whenever it is written a male child, you have to do plus 6.5, and whenever it is mentioned girls or a female child, you have to do minus 6.5 by a value of father's height plus mother's height by 2. Okay. One more MCQ which always come across in MCQs, and you can even see in a recent past questions, that is when a child is having a short stature. When a child is having a short stature with infantile body proportion, this is a sign that a child can be suffering from achondroplasia. It can be a sign that a child can be suffering from achondroplasia. Or along with that, you can name it as short-limbed dwarfism. It can be short-limbed dwarfism. It is a sign of achondroplasia. Am I done with this thing? So moving with the further, a question can come across to a question that what is the percentage gain in weight at the end of first year of life. Yes, what is the percentage gain in weight at the end of the first year of life? Now, if you remember, I just now mentioned about ready reckoners. Yes or no? है ना? तो बॉडी वेट हमने क्या देखा था? बॉडी वेट when considered to be x at the time of birth. Yes or no? And what we talked about at 1 year. At 1 year, it is considered as to be 3x. So what is gain? Gain is equals to nothing but it is 3x minus x, which is equals to 2x. This is your gain. Now what is asked in your question is percentage of gain. So let's do further. How can you do this? So gain percentage equals to 2x upon x multiply by 100. Why you multiply by 100? Because you want to get your answer in percentage. So 2x by x into 100 2x by x into 100. So x will be cancelled out. So it will be 200 percentage. So what is an average gain percentage in weight? Average gain percentage at the age of 1 year of life, it is 200 percentage. Am I done with this thing? I hope you understand this. I hope this is clear. Similar kind of question can be, you can see on your screen or while you are doing it, while you are giving your exams, that what is the percentage gain in height at the end of the first year of life. What is percentage gain in height at the end of the first year of life? Again, we follow the same thing. Remember ready reckoners. So what was ready reckoners? What is ready reckoners? What we looked about, average height of a baby when it is when it took birth, it is 50 centimeter. At the age of 1 year, it became 75 at an average. So what is gain? Chalo, let's do with me. 75 minus 50 will give you how many? 25 centimeter is your gain. So what you want to do is, now we want to get is gain percentage. So what is your gain percentage? How much it was? It was 25. And what was an original value? What is x? It is 50. And you are going to multiply by with 100 as you want it. Your answer is in 100 percentage, because in the question if it is asked what is gain percentage. So 50 twos are. So that is 50 percentage. So what is your gain percentage? In height, it is 50 percentage at the end of the first year of life. It will be first year of life. Okay. So now we are going to talk about ratios. We are going to talk about certain ratios of US and LS. You may have a question, what is US and LS? So it is nothing but it is US is, it is upper segment. US is nothing but it is upper segment, and LS is nothing but it is lower segment. So there are 3 or 4 ways what you need to, there are 4 or 5 values in terms of ratio what you need to remember. The first one, it is at birth. It is at birth. So at birth, it remains at 1.7 raised to 1. See, it is 1.7 raised to 1, or it can vary from 1 raised to 9 to 1. This is a ratio of upper segment to the lower segment. So what is the ratio? At birth, it is 1.7 raised to 1 to 1.9 raised to 1. I hope it is clear. It is raised to. Done? So, next. What you can see at 3 years. At 3 years, the ratio of upper segment to the lower segment decreases from 1.7 raised to 1. 1.9 raised to 1, it decreases to 1 point, sorry, it decreases to 1.3 raised to 1. 1.3 raised to 1. Now, the third one, it is at the age 6 to 7 years of life. It is at the age of 6 to 7 years of life. It is 1 raised to 1 to 1. So basically what is going to happen at the birth, ratio will be maximum, and as the child takes growth, child growth takes place, the ratio is going to decrease. So what will be situation at 8 to 10 years of life? It will be 1 raised to 1. So now the interesting one, what a question can come. At what age the ratio of upper segment to lower segment becomes same, or it can remain equal? It is at the age of 8 to 10 years of life. What happens at the age beyond 10? What happens at the age beyond 10 years? Adult ratio, it will be similar to adult ratio, that is 0.9 raised to 1. It will be zero point 0.8 raised to 1. I hope I'm clear with this. Yes. Okay, now moving to very much theoretical part. Yes, that is about head circumference, chest circumference. Head circumference is this, we measure with a tape. So, key points to remember, or we can say it is even one liners to remember about head circumference and chest circumference. Okay. As we discussed about ratio of upper segment to lower segment, now we are going to discuss about circumference of head circumference and chest circumference. So, now always remember, at birth, I'm denoting head circumference as HC and chest circumference as CC. I'm again writing over here. Okay. Head circumference will be more than chest circumference. Please, head circumference will be greater than chest circumference at the time of birth, which is nearer by 3, 3 centimeter, which will be nearer to 3 centimeter. This ratio will be. But at what age and what month does the ratio of head circumference to chest circumference will be equal? Will be equal. It will be at the age of 9 months to 12 months. It will be 9 months to 12 months. So, on the contrary side, at what time chest circumference will be greater than head circumference? It will be nothing but it will be beyond 12 months of life. Or it can be question. In a question, it can mention at the age of, at the time of infant, when a child becomes infant, or it is even here I have mentioned it is beyond 12 years. I mean, sorry, beyond 12 months. Yes or no? So now there can be one possibility. What if head circumference continues to grow, continues to be greater than chest circumference, even post infancy? At what time? Even at post infancy. What can you suspect in this child? If head circumference continues to be greater than chest circumference, there can be a disease. So as for the criteria, what we saw that basically head circumference to chest circumference ratio decreases. But on the opposite side, if the ratio continues to grow, there are two possibilities that a child can be suffering of. There are two possibilities where a child can be suffering from. The first one is hydrocephalus. A child can be suffering from hydrocephalus, or second is severe malnutrition. If a child is not getting proper nutrition, it can, this can be an indication that child is suffering from malnutrition.